the summation of x to power n, and start from 0 to infinity, can be written as 1 plus x squared plus the rest of the terms. And in the case that the ratio is bounded between -1 and 1, or absolute value of x is less than 1, this guy is convergent to the function 1 divided by 1 minus x. And remind yourself of this series, which is basically a geometric series. And in general, if you have the summation of a quantity to power n, and start from 0 to infinity, this guy, as long as the absolute value of that quantity is less than 1, it is convergent to 1 divided by 1 minus that quantity. So this is the pattern that you're following. If it makes it easier for you, this is the pattern. Let us take a look at this question. You want to find power series representation for x cubed divided by 2 plus x. What I'm going to do, I'm going to find power series representation for 1 divided by 2 plus x first. First, I try to find power series representation for 1 divided by 2 plus x. Why is that? Because it has a similar pattern to the summation of the quantity to power n, which is 1 divided by 1 minus that quantity. Let us do a little bit of algebra. By doing algebra, 1 divided by 2 plus x can be written as 1 divided by, I'm going to factor out 2. I end up with 1 plus x divided by 2. So here I factored out 2. Now I'm going to rewrite the quantity inside parentheses as, so here I have 1 divided by 2, open parentheses, 1 minus, open parenthesis again, minus x divided by 2. So minus minus, they get canceled out and you get the exact same original quantity that you already have. But it helps me to write this guy in terms of the pattern that I have up there. So basically now you have 1 divided by 2 times 1 minus a quantity. And this quantity is nothing but negative x divided by 2. This box is negative x divided by 2 inside this parenthesis. Very good. So 1 divided by 2 times 1 minus negative x over 2 can be written as, I'm going to write a half in front of this quantity, 1 divided by 1 minus negative x divided by 2, and follow the pattern. The pattern says, hey, as long as this quantity has absolute value less than 1, it is convergent to 1 divided by 1 minus that quantity. So as long as negative x divided by 2 in absolute value is less than 1, this series, this function, has a power series representation of the form summation of negative x divided by 2 to power n and start from 0 to infinity. So again, as long as absolute value of x divided by 2 is less than 1, if you want to see algebra, you can write it this way. You have the absolute value of x divided by negative 2 less than 1, or the absolute value of x divided by 2 is less than 1, or absolute value of x is less than 2, or x is bounded between negative 2 and 2. As long as x is bounded between negative 2 and 2, we can write 1 divided by 2 times 1 over 1 minus negative x over 2 as, so I'm going to copy this coefficient a half times the summation of negative x divided by 2 to power n and start from 0 to infinity. So far we showed that 1 divided by 1 plus x, so 2 plus x, is a half the summation of negative x divided by 2 to power n and start from 0 to infinity. You can rewrite this, do a little bit of algebra. This is the summation of negative 1 to power n times x to power n divided by 2 times 2 to power n and start from 0 to infinity. So far, we have 1 divided by 2 plus x equals to the power series negative 1 to power n, x to the n divided by 2 to power n plus 1, and start from 0 goes to infinity. This is what we have so far. Let's see what we did. Take a look. Remind yourself of geometric series, the summation of x to the n, which is 1 plus x squared. As long as absolute value of x is less than 1, it is convergent to 1 divided by 1 minus x. Or in general, if you have the summation of a quantity to power n, as long as the absolute value of that quantity is less than 1, it is convergent to 1 divided by 1 minus that quantity. The question says, find power series representation for x cubed divided by 2 plus x. I started by finding power series representation for 1 divided by 2 plus x because it's easier to find a pattern for this. Then we can do the multiplication. And so far we saw that we can write this guy as 1 divided by 2 times 1 minus negative x divided by 2. So let us fit that into this pattern. As long as the absolute value of the ratio, which is negative x divided by 2, is less than 1, this function has power series representation of the summation of that quantity to power n and start from 0 to infinity. So as long as your x is bounded between negative 2 and 2, this function has power series representation as negative 1 to power n, x to the n divided by 2 to power n plus 1. Now all you need to do is to multiply both sides by x cubed. Finally, all we need to do is to multiply both sides by x cubed to construct x cubed divided by 2 plus x. So let us begin. X cubed divided by 2 plus x is equal to x cubed times the power series that you have. the summation of negative 1 to power n, x to the n divided by 2 to power n plus 1, and start from 0 to infinity. What's the meaning of that? It means that you are distributing x cubed into parentheses. When n is equal to 0, what do you have? You have 1 divided by 2. When n is equal to 1, what do you have? You have negative 1 times x divided by 2 squared. When n is equal to 2, what do you have? You have negative 1 to power 2 x squared divided by 2 to power 3 plus the rest of the terms. So what are you doing? You are just basically distributing x cubed into parentheses here. A half minus x over 4 plus x squared over 8 minus x to the third divided by 16 plus the rest of the terms. So if you distribute this into parentheses, these are all equal to, now you have x cubed divided by 2 minus x to the fourth divided by 4 plus x to the fifth divided by 8 minus, now you have x to the sixth divided by 16 and so on. Isn't that interesting? So what happened here? We only changed the power for x, all right? Now your x is just has power n plus 3. So to summarize everything, x cubed divided by 2 plus x can be approximated by the summation of negative 1 to power n, x to power n plus 3 divided by 2 to power n plus 1, and start from 0 goes to infinity. And please note that your x is bounded between negative 2 and 2, or the interval of convergence is open interval negative 2 to 2.